Hello everyone, my name is Wasim Jabi. I'm a reader at the Welsh School of Architecture at Cardiff University. In this video, I'm responding to a couple of requests that I received on LinkedIn and Twitter, I think, regarding the image that you see here on the screen. People wanted to know what is the workflow behind it. So basically, just to explain it a little bit, the workflow is quite simple. It's very short type of workflow. In the upper left corner, you have Dynamo and Topologic working within Dynamo. So if you don't know about Topologic, just visit the website topologic.app, and you can learn more about it and download it as a plugin for both Dynamo and Grasshopper. So in that upper left corner image, we are basically exercising a parametric building where two wings of that building can move and change size as you wish as a designer, and then you can calculate certain things in it, especially in this case, the energy performance. In the lower left corner is that same file exported from Topologic Energy into OpenStudio. So OpenStudio still has a graphical user interface. This might be discontinued, by the way. So I don't know, NREL, I think, is changing plans a little bit. But in any case, you can output an OSM file, or in the new version of Topologic, you can output directly a gbXML file that you can open in different pieces of software. So in the lower left corner is OpenStudio, and in particular Data Viewer, and you can do time series. As you can see here, you can change to hourly, daily, or monthly, and you can see different results. And on the right side in the large window is the same file again as a gbXML file loaded in the online Ladybug tool, Spider tool that we have here, which is an open source tool. So that whole process, as I said on LinkedIn and Twitter, that it is almost all open source, because Spider is open source, OpenStudio is open source and free to use, and Topologic is open source and free to use. Obviously, Dynamo is open source, but you need Revit, and it's still not 100% perhaps. And if you are using Grasshopper, obviously Grasshopper is not open source, or Rhino is not open source. But let me show you how this whole process works and give you a bit of tutorial on Topologic. So I'm going to minimize this. So here it is in Topologic, and this is the graph in totality. So we'll go through it step by step and show you how it works. In order for me to do that, what I'm going to do first is I will freeze some nodes, and I'll come and revisit them later on. Actually, I'll leave that on. I'll turn that to false, and we'll run it one more time. Okay, so let's go ahead and look at step number 1, which is to create the first building wing. So very simple definition, really. It's all about creating cuboids or cubes that have a certain width, length, and height. In this case, 15, 10, and 3. Everything is assumed to be in meters. And you can also change the number of units on each direction, in the width direction, length direction, or height direction. So you can change the number of floors, for example. So now it has 4 floors. So once you have built one wing of this, you can now change its position as a whole set along the X position, and I'm allowing a certain position from 0 to 2. You see here I'm setting this as input for a refinery study for multi-objective optimization. That we're not going to cover that in this video. A set of cubes or cuboids in one direction. And then in step 2, we are doing the same thing now, but for the other direction at 90 degrees to the first one. And you can change that as well. So let's go ahead and exercise this, for example, like this, and run it again. and we have to wait. I'm going to go ahead and turn on the stopwatch so that you can get a feel for how long these things take. I am on a fairly weak old laptop, so don't be bothered by the fact that the colors have not moved, simply because those are remnants from the previous analysis, but focus perhaps more on the wireframe. So you can see that it has moved. So we can, let's say, move the X position to 0 and run it again. All right. So you can, as I said, move this building in any way you want. As I said, please ignore the colored cubes. Just focus on the wireframe. This is the current status of the building. Right. So we have built, just to continue the process, we have built kind of a series of cuboids. We've translated them to the right location. Here we have made a list of them. We joined the two lists. So we have now a list of cuboids. We then flatten the list, and basically that's what we have at the end. So it's a list of 28 cuboids in this case. Now, those obviously are overlapping, or some of them are overlapping. So when you create a topology, everything gets cleaned up. You don't have to worry about any overlapping faces or overlapping cells or anything like that. Now, this is the first node in Topologic. It's called Topology by Geometry. We have, by design, created only two nodes, one for an entrance and one for an exit. So to enter into Topologic, you use topology.byGeometry, and you convert any Dynamo geometry into its equivalent topologic topology. You don't have to worry about saying, for example, cell by cuboid, or cell by cylinder, or cell by sphere. If it is a cylinder or a sphere or a cuboid or whatever it is, if it can make a cell, you just simply feed it into topology.byGeometry, and it will convert it to the correct equivalent in Topologic. So you'll notice here I have a set of 28 cells that are equivalent to the 28 cuboids. Now those are still, some of them are still overlapping, so I don't actually have, I shouldn't have 28 cells, I probably should have less. As you can imagine, some of these here, these two cubes, for example, these two small spaces are overlapping from each side, so those will need to be cleaned up. So it will create exclusive spaces and no overlapping faces or anything of the sort, or edges or vertices. But how do we do that? We basically feed all these cells into another topologic node, which is called cellComplex.byCells. And this one just simply takes in all the cells, gives you a very clean and merged cell complex. And the cell complex is quite intelligent. You can ask it all sorts of questions about shared faces, shared edges, neighboring cells. You can get a cell out of it and say, give me your neighbors, and it will give you that. It's called cell.adjacent cells. Right, so we've built the cell complex. All right, we can visualize it. That's absolutely fine. As you can see here, I'm getting the edges of that cell complex. And again, those edges that I'm getting here from the cell complex are the exclusive edges. They are not overlapping in any way. So you can get an accurate quantity of right. So now we come to the interesting part, hopefully, which is we have the cell complex. How do we do an energy analysis out of it? So we have this node, which is called energy model by cell complex. Let me unfreeze it so that you can see it. It's a fairly large node because it has a lot of these input parameters. Let's go through them one by one. So it assumes you are modeling a building, and the building is the cell complex from the cell complex here all the way down to the building. Optionally, you can feed it a cluster. A cluster is another topologic class that we have, a cluster of faces. So you can have any face you want. You can create a face, some planar or anything like that, or triangles, and make a cluster out of them, just grouping them into one big cluster. These could be shading devices, let's say, out on the outside of the building. They can also be neighboring buildings or trees or obstructions of some sort that you want them to shade over your building, and you can feed them in here. Again, it's optional. Floor levels is basically a list of numbers that indicate the Z levels that you have in your building. And this is useful because then it can compare the spaces to those levels and assign them based on their finished floor level, for example. It's just, again, it's optional, but it helps assign a certain space or a certain cell to the correct story or correct floor level that you have. So you can see here, let me zoom out just a little bit. You'll see here, I'm creating floor levels from 0 to the height units multiplied by the height. I'm assuming both wings have the same height unit to height. So let's say from 0 to 30 in 3 meters, let's say, or from 0 to 12 in 3 meters. It just, as I said, it creates a list of floor levels. Right, so after floor levels, we have building name, which is an optional name, just a string. I'm going to Autodesk University to give a class, so I'm calling this building Autodesk University. Building type is commercial, and this just indicates the kind of constructions that it's going to be using. The default space type is a medium office, which comes from the template that we will be loading. And at this point, Topologic Energy uses only a single space type. So all these spaces, that you have in the cell complex are all offices. We're going to try to change that in the future to give the user the option to choose different space types, but you can also change it after the fact, after it has been built in OpenStudio, and I'll show you a little bit how that happens. Right, then the north axis, just to indicate where north is, it's an angle in degrees, where 0 is in the positive y axis, so pointing upwards. Then if you have not designed your own windows, which you can, and you can add them as apertures in Topologic, so you can create a cluster of faces and add them as apertures or windows. But if you have not done that and you just want to give a general glazing ratio, you can do that here. So in this case, we have a 30% glazing ratio, which means 30% of the exterior walls are covered with windows. After that, it's the cooling temperature and the heating temperature. And those are the temperature, for example, for the cooling temperature, it's at the point at which the cooling system, the HVAC system kicks in, and the heating temperature is when the heating system gets in or kicks in. So we're setting them at 25 degrees Celsius and 20 degrees Celsius. Then we need to tell it where it is in the world. So we need a weather file and a design day file, and those you can download from the US Department of Energy. They have them. So in this case, the weather file that we are loading in is in Athens, Greece, for both the EPW and the DDY. This is just a file path. And then we do include with Topologic Energy a template which is compatible with OpenStudio 2.8.0. The latest version of OpenStudio is now at 2.9, so hopefully we will upgrade soon. But if you are going to use this, you have to download OpenStudio 2.8.0 and install it on the C drive. And this template is simply a file that has all the constructions, the space types, etc. That's where that medium office name came from. You know, this one. This is embedded in this template file. Right. So after this runs, it creates what we call an energy model that has all the information ready to go, ready for simulation. And then we drag and drop another node that is called energy simulation by energy model. In this one, we are feeding it the energy model that we just created. We are feeding it the .exe file for OpenStudio. As I said, we are compatible with 2.8, so you have to find this file. It's called OpenStudio lowercase.exe. There's another one with a similar name. Don't get confused by that. This is under bin OpenStudio.exe. And then you have to create an empty folder, any folder you wish, in order to save all the energy analysis output. So I created a folder called energy analysis output, and this is a directory path, not a file path. Just be careful with that one. But before you run this, you have to change this to point to a folder on your computer. Then the last one is whether you want to run it or not, because this can be time consuming. So I gave it a toggle, a Boolean flag, whether it's true or false. And once I set it to true, obviously, and run it, it will run the actual simulation. So now it will run, it will open up a command window. You will see some error messages or warning messages. Those are known to be kind of generated by OpenStudio. They told us that it doesn't really affect anything. They expected it. It runs correctly. And then that energy simulation is fed into another node now to get results out of that energy simulation. So this is called simulation result dot. And the energy simulation that we just created. And then if you know about the report and the strings and the tables and the columns that are generated by Energy Plus, you can type them in here. So there is an SQL database that is generated by Energy Plus that we read back into Dynamo without having to do, file export and import to get the colors. So in this case, we are looking at a report called HVAC sizing summary for the entire facility, and we're looking at cooling loads, and we are getting a column that is called user design load per area. So it's not just in watts, but it's in watts per square meters, and you have to give it the units that you are expecting to see there, which is watts per square meters. Get all sorts of things out of it. One thing you can get out of it is the values. So in this case, we haven't run it, obviously. It will give you a list of values, and we are just simply here doing the average of those values. And then you can also get the colors. That's how you see those rainbow colors, and we do a gradation, correct gradation, around the color wheel, from a very cool dark blue to red. So that dark blue means very low value, and red is a high value. And you can also change the domain, or you can keep the same domain between energy runs so that you can have a comparative way of looking at the data. So you can bracket the colors to a certain domain, and that's based on the values that you are getting. So you can definitely say, feed it in a minimum domain and the maximum domain, and it will give you the correct colors. So this is a little bit of Dynamo work to get from the RGB values to be able to create a color, and then display that you feed it the energy model that has the geometry in it and the colors, and it gives you a Dynamo geometry color output. So let's go ahead and let me go ahead and run this. So what I have to do here is set this to true and run it. As you know, out of that, Dynamo does crash sometimes on its own. So we've seen a bit of crashing happening sometimes, so hopefully this one will not crash. We're always trying to debug it and see if it is our fault or Dynamo's fault, and sometimes it's a bit confusing. Okay. Here we go. So this is now OpenStudio starting. As I said, these warnings are expected and they don't affect anything, as we were told by NREL. So this window will stay up for a while it is running an annual kind of run. Okay, it is done. And these are the colors. These are the values. So if we go ahead and look at the values here, we should have some numbers in there. And they are there. And the average is 45 watts per square meters. In addition, now, which is what you saw in the tweet, we can export this energy model that we have to both OSM. In the previous version, when I tweeted, we were on a previous version, and OSM is basically OpenStudio model, which can be read into the OpenStudio application. And now with the new version that we are about to announce, which you might already have by the time you're watching this video, we can export directly from Topologic to gbXML. So we just give it a file name, and we feed the energy model, and if it is successful, it will give me a true Boolean at the end just to tell me that it has been able to export it. So yeah, so this is the building. That's how it looks like. Obviously, these red cells are on the south side, and they're getting the most exposure to the sun in Greece, and these cells here are cool because they are protected and shaded on the west side. Right, so we are going to take a look now at both the OpenStudio file and the gbXML files. So as I said, you have to download OpenStudio, and this is OpenStudio GUI. Okay, just wait for it for just a couple of seconds for it to activate. Okay, and then we can open the file. We call it test.osm.osm. Okay, so again, like this. And this is really the database of the energy model. This is the equivalent of the energy model in Topologic. And you can see everything is in here. And you can start, if you know how to use OpenStudio, you can go to the library and start changing things here. I'm not a big OpenStudio expert, to be honest with you, but everything is in here, and you can change it any way you want. You can also do a different run, which is similar to what we've done before. So we can click run, and it will do exactly the same thing. So again, if you want to advance the video until this is done, then I will show you the results, because this might take exactly the same amount of time as it did in Topologic. So it was done. So now you can get the report as usual from Energy Plus. So you have all the data that you need. For example, the HVAC sizing summary is right here. And you can see these are the numbers that we are using, the user design load per area, let's say, for the cooling. But you can also open what is they call DView data viewer. To see a bit of time series charts. And you can choose which one goes at the bottom or the top. Again, it's up to you really to decide what you want to see for a specific thermal zone. You want to see the relative humidity, etc. for a zone. So, but the other more interesting things perhaps is the ability to output directly to gbXML. And you'll notice that it is right here in the new version. We could have outputted to gbXML from OpenStudio as well. They have a export to gbXML, but now you can also do it from Topologic. So here it is, and there it is here. So how do we see this? Basically, you can open what is called the gbXML viewer, the spider viewer here, and you can just simply point to the file, and you can get your file here. Hide this, hide that, and there is your gbXML file. It's usually very clean. All the information is in there in order for you to move it to something else for analysis. And you can investigate, obviously, the spaces. They're all named, all the zones and the surfaces are named by the story number and the space number, so you can kind of trace them really well, and you can click on them here and check what those faces are. That's it. I hope you enjoyed this. If you have any questions, please contact me at my email address on Topologic, for example. It's info@topologic.app or at my Cardiff University email address. I'm sure you can find it very easily. Thanks again.